Hi everyone, really excited to be here at this awesome event. For today, we will try to show you how you can design your own sniping bot for decentralized exchanges on Fantom, and also how you can get easy access to the Fantom blockchain using our platform. But first, let me make the introductions. We have Alex over there. He's our smart contract expert. He'll get into all the technical details that are required to get a trading bot working. And then Flavian, our CEO, will show you how you can get easy access to the Fantom blockchain using our platform. I'm Radu, I'm a product manager at Bware Labs, and my role for today is to make these presentations, and also I will tell you a bit about what it is we are trying to achieve at Bware Labs. So, not sure if I can say it more clearly than it is on the slide here, but mainly the idea of Bware Labs revolves around connecting node providers and API consumers of whatever nature, whether they are decentralized applications, decentralized exchanges, or wallet providers, and so on, to the node providers. This is being done in a mutually beneficial way, in which the API consumers will get reliable and fast access to a geographically distributed infrastructure, where the full node providers will get paid by simply hosting their nodes and fulfilling requests. So this is pretty cool, right? Why we thought about this? Well, we strongly believe that all blockchains in the crypto space should benefit from the same level, or at least similar levels of tooling. And I think we all wish that we would have the same level of access, and when we decide where to build our products on which blockchain, the fact that we don't have access to the necessary infrastructure shouldn't be a factor for that decision. So on the market today, for developers, it is pretty difficult, almost impossible to find reliable infrastructure, that's API infrastructure, to build upon. And usually they have to host their own full node and do all the work necessary to maintain it and keep it going. So the market providers today are focused mostly on Ethereum and a handful of other projects, and we think this puts a tremendous amount of pressure on up-and-coming projects, cool projects like Fantom, for example, to basically offer their own infrastructure if they want to encourage adoption. Also, for developers, it's pretty difficult to find the necessary infrastructure needs in order to build their products on their blockchain of choosing. How we plan to solve this issue at Bware Labs? Basically, we are presenting a hybrid solution where node providers can plug their nodes into our platform and they can get rewards for fulfilling requests. On the other side, the API consumers or blockchain builders can get access to a fast, reliable, and geographically distributed infrastructure cheaper than ever before. So we will have a Q&A session at the end, if you want to wait for that. Thank you. So basically, we have implemented a protocol that is monitoring and enforcing good behavior on the part of node providers. The good behavior I'm referring to is in terms of reliability, in terms of response time, and most importantly, in terms of data integrity. The providers that manage to fulfill all these requirements will get distributed the funds coming from the builders that are having subscription into our platform. Bware takes a little cut of this. If you want, it's basically the Uber model of business. Also, once our token will be released, the node providers will also get the option to stake Bware tokens and increase their revenue getting an APY. I hope I gave you an idea about what it is we are doing. We are also around for the next days if you just want to chat, and we'll have a Q&A session at the end. Now, before giving the stage to my colleagues, I have a little hint for you. Our CEO will have an announcement at the end, so bear with us for the entire presentation. I think it would be good. Now I will invite Alex on the stage for the more technical and I think more interesting part of the presentation. Thank you.
Thanks, Radu. That was wonderful. Firstly, I will start with a question for the public. How many of you guys ever used a decentralized exchange before? I see, that's great. And following that up, how many of you really wanted to be among the first ones to buy at listing tokens? Yeah, me either. Basically, we designed a trading bot months ago in order to address this scenario. And we split it up, the content, into multiple stages. The first part, the first topics are related to the mechanism of the DEX trades and the theoretical part of that, and following up with how you can implement a simple trading bot for that scenario, and also some improvements that we can think of but never implemented. In the first bit, DEX trade is operating on pairs of tokens. Basically, you trade token A for B. And this process is following the product formula, which says that the product of supplies should always stay constant, no matter what trades happen on the decentralized exchange. Because of that, the price of the token, as you can see it off-chain on the UI provided by the exchange, can change from the time you broadcast your buying transaction to the time it is mined. For that, there is a mechanism which acts as a safe net that will let you specify the minimum amount of tokens you want to receive after a trade. If that fails to be honored, the transaction will be reverted. So we'll be we won't be at the risk of buying tokens at higher prices. And I introduced that slippage threshold because in the implementation we will have to disable that in order to ensure we get the buying transaction as fast as possible. Firstly, I will follow through some simple steps on how you can be the one detecting the liquidity. As mentioned in the previous slide, the product formula and the constant K is given at liquidity injection time and will stay constant. So the pair on the exchange will be tradable once that transaction is being mined. In order to detect it, you can use libraries such as Web3 in JavaScript or Python and make use of pending transactions filters provided. The fact that the library doesn't provide a complex way of filtering, it means you have to do it yourself by ruling out all the pending transactions not addressing the DEX contract, and then filtering out by method signature, and then by the argument which adds liquidity to a specific pair, because you target basically just one pair that will get listed in the future. So we talked about how you can detect the liquidity itself, but now we have to move to the stage where we broadcast the buy transaction. Basically, we have to talk about the life cycle that it gets through and how we can make it behave exactly like Liquidity one. So the purpose is to have it mined exactly after the Liquidity transaction in order to be able to trade, but before others. And the flow is simple. The transaction is being broadcast. It's added to a global pool of pending transactions waiting to be gathered by a validator and added to the blockchain in the next node, in the next block. Usually, in proof of work consensus, these transactions are sorted out by the gas price because the miner will try to maximize their profits. In the case of proof of stake, usually the secondary ordering is by time of arrival. So the time, the transaction it gets to the global pool, which is in the order that they get to that. So we'll move next to the next slide. In order to disable that slippage threshold we talked about earlier, we do so by implementing a swapper contract. Basically, you can compute the exact token price within a transaction. So within a smart contract that interrogates the reserves directly from the DEX. With doing so, you can get the exact amount, the exact minimum amount, and can disable the revert of the transaction, ensuring your buy is passing through all the time. Another advantage, but let me go to a diagram. Another advantage of the swapper is related to how you can scale up the network of bot instances. Because, as we talked about, the time of arrival is something quite important. And to do so, to maximize your chances, you may want to scale up geographically the network of instances. In order to do so, it will be easier to store all the assets you want to invest, to trade directly on the contract, and have all these instances connected to wallets acting just as triggers. In order to delve into the technicalities of how you optimize the time of arrival, we have to talk about the entities involved. The first one is the entry point used for listening for add liquidity, the endpoint you are using. The other one is the node that's broadcast the transaction in the first place. And the third one is the validator that will mine the block containing the liquidity, not especially the buying one. And in this diagram, this is more clear. We have the liquidity source and the miner or validator, depending on the consensus. So you will get the broadcast of the liquidity. These are the black arrows. And once that's detected, each of the instances will broadcast their own buying transaction. Basically, just the first bot mining the buy will use and spend the funds, and all the others will fail. Why is Bware Labs important in this context? Because we guarantee distribution of locality of the endpoint. So basically, you can set up multiple projects in different geographical areas and connect all your bot instances to that. It's not enough to only set up a network of instances which is in the same area. You have to cover it globally. And the other argument is the fact that scaling up is costly. And we promise like a lower price on that. And the last argument, which is quite empirical, is the fact that there is a slight chance of having the source or the sink, so the validator or the source of add liquidity already registered in the platform. We focus mainly on the buying transaction and how we can front-run the competitors or be the fastest, but we also have to think about the selling strategy, and this can be done in a quite simple way. Firstly, setting up a loss and a profit target percentages, and there are two flavors afterwards. The off-chain option will be to interrogate the price of the token, but that's the real value only at the end of each new mined block. In order to sample the price in between blocks, one possible strategy would be to also use the swapper contract presented before and automatically revert if the price hasn't hit any of the thresholds. And about further improvements that we haven't implemented before, the first one we already discussed is the scaling up of the network of bot instances. And the second and the third one are somehow related. They mean modifying the Fantom full node in order to filter out the pending transactions, which can be a lot of them, at the level of the peer-to-peer module. And also, reactively, send the transaction once found directly to the bot. In this way, the bot becomes the server and the node becomes the client of that, instead of polling it via Web3. And the second idea would be to connect all the bot instances and create a full mesh. So use a different channel, transmission channel. Doing so, when the liquidity is detected by one of the instances, it can be broadcasted, as you can see in the dashed line, directly to all the other. In this way, there is a possibility of skipping up some hops in the peer-to-peer network provided by the blockchain. So you use your own connection. Because the instance closest to the liquidity source is not especially the closest to the validator that will add a node. So you have to minimize the sum of distances, really. The one from the liquidity source to one of the bots, and the other one up to the validator. In terms of real-world applications, this paradigm can be used, this configuration can be used to estimate prices and guarantee the price you want to get for a token trade. So basically, it can be extended to achieve limit orders on DEXs. Another use case that I forgot to mention in this slide is NFT minting, because both of these processes are based on the same principle. You wait for a transaction that will enable some trade of an asset. Now I'll move to the demo part, where I'll show you a scenario where we can use a trading bot on Spooky Swap. Just a second. All right, okay. So basically, I have deployed a swapper contract on Fantom, and I have two instances of the bot that will start. Okay. Oh, sorry about that. Just a second. So I started the first instance and the second one. So basically, I started two instances with two different wallets. They saw that I have one Fantom token to invest in a trade, and with a third wallet, which is this one, I will add liquidity to a token that I've created before the presentation. And we'll see how it how it's being done, and the fact that a buy is triggered. As you can see, the buy transaction has been detected, the liquidity has been detected. There is a number of blocks that pass until the selling is happening. So basically here, we detect the liquidity transaction, the other bot failed because the reserves, the one Fantom token has already been used for the trade. And here, the price is being checked off-chain for the selling strategy. But because no other trade is happening on the DEX, we expect to get back the same amount. So after a number of predetermined blocks, I trigger the sell automatically. And we can see the transaction on the Explorer. Oh, it's better to look at the contract itself. So basically, there were 2 buy transactions. The second one fails because it was the last one. This is trading Fantom for the token itself, and here is the sell one. And this is how it works on a simple use case. Now I will let Flavian talk more about the product we're developing and the aims we want to achieve.
Hey guys, thank you Alex for the nice presentation. Okay, so let me bring some insights about what Alex has shown. Actually, we have used this this bot in production earlier in earlier this year, and we used it on Uniswap. And it was like a side project for us, very fun to do. It was something that we were curious about, and that's how we developed until a certain point where we focused on other things. But given so, let me showcase how easy it is to obtain an endpoint in our platform. So we can head up to app.bwarelabs.com. And here we can see we are on the dashboard, and we can see the number of supported networks. And right now we are supporting Ethereum, Binance Smart Chain, Avalanche, Polygon, Moonbeam and Moonriver, Shiden, and of course Fantom. The number of active endpoints right now, it's above 4,000. And given so that the platform is in alpha release, we already have projects using us in production. So let me go further with what is needed to run the app. So firstly, we will need a MetaMask account and plugin installed, and also an ERC20 account added to MetaMask. So let me just connect to an account that hasn't been used, just to show you the whole process. Okay. MetaMask is only used for authentication at this stage. So let's say launch app. And now we have 2 options. First, to become a node provider, which isn't available in this alpha release, but also get your own endpoint. At this stage, all the nodes that are behind the platform are hosted by Bware Labs, but in the future, and in the near future, external node providers will be able to join the platform. So we haven't generated yet any endpoints, so we can say get started now. And select Fantom, select testnet, for example, and say give it a name like Fantom DC. We say create endpoint. It will ask for a signature we signed. And, oh, doesn't work. Actually, I'm kidding. It always works. So right now it's in a pending status. Until then, we can go on the docs. And a simple way of showing that the API is working, we can query the latest block. For example, Ethereum block number. And we would need a curl application to run that. So we would do like online curl. Okay, we can copy the request. I have big fingers, so a little bit hard to work on Alex's laptop. Okay. So this would be the request. I just need to change the endpoint to be used from Bware Labs. Let me go to the platform. We see now that the status is running, and we can copy the endpoint. We paste it here, and we say run. And we can see that we have a hexadecimal response. We can, for example, use a converter like hex converter. And let's simply add it here. The result, we convert it, and we receive the decimal number. We can compare it with the Fantom scanner. Testnet to compare the two results. Fantom Testnet Explorer. Okay. So we can see that the latest block it's quite near because of the delay of me finding the Explorer and everything. Also, another really interesting use case is that you can directly add the endpoint to MetaMask and use it to see your tokens and everything in that regard. So we can say approve, switch network, and now MetaMask is using this testnet that was generated on the platform. And as you can see, we already have some Fantom tokens in the wallet. So that means it works perfectly and ready to use in MetaMask as well. As my colleagues were mentioning, there's also a surprise from our side. So in this quarter, we will be launching our token, which will be the fuel of the platform and the decentralized API service. And also at the same time, node providers will be able to join our platform by staking our tokens and being an active participant. So if there are any of you who has some nodes running, please feel free to reach out to us, and we can surely integrate you into our platform. So that being said, we are now open for the Q&A. Are there any questions from the public?
Hey guys, I might have missed this, so I do apologize in advance, but do you essentially interact with every new verified contract, or is there a sort of like sorting procedure for you to interact with contracts either like based on a certain criteria that you've established or through code essentially?
This is a question for Alex.
You mean the swapper contract, right?
Like, do you interact with on the Explorer all the new verified contracts that come out, or do you sift through new verified contracts on the Explorer and only selectively interact with whatever you have deemed to be worthy of putting bids, essentially?
Well, basically, so firstly, the swapper is something custom, is a contract implemented by us, which acts just as a wrapper for the operations allowed on the DEX.
I think I can answer this as well. So basically, you will have to do your own research on what tokens you want to. Oh. So you basically need the smart contract address of the token that you want to buy on
so
the
basically, you have to be fishing those pairs that will be added and start listening for the liquidity with some hours in advance of the listing, depending on when it is announced. It's not like detecting all the liquidities, but that can be an extension. It's not the listening all the time for all the liquidity added for X pairs of tokens.
Got it. Thank you.
My main question here is, how do you ensure that the pool of RPC or WS providers is a healthy pool, so to speak? Like, the nodes are maintained healthy manner, so there is no interference from the node operators as they have the direct access to those servers?
So basically, we have an integrity protocol that works in the platform. And what it does, it queries all the nodes and mirrors some calls that have been made by the clients and ensures the overall health of the network. So when a node goes out of sync and it's not at the highest peak, it gets out of the pool, basically. So it's an automatically mechanism to ensure everyone is at its best performance.
So basically, we test firstly the performance by latency, syncing time, and this kind of stuff, which is required for good usage. But we also test the integrity of the response itself. This is not a comprehensive strategy because theoretically it's impossible, but we do that by sampling and mirroring the requests made by the users in sources of truth we know in advance and compare after that. So we can discard any nodes that are misbehaving.
Thank you. So a follow-up for that, when you have multiple nodes as a decentralized pool, so they're all probably using different hardware. So how do you ensure that some of them might be stronger and some weaker? So the load balancing would be different for each node or would be on a network basis for all the nodes participating for that particular network? So
actually, one important thing about having a good latency is to route the request as close as possible to the sender. So if I have a client in Europe and it's using our platform, we will make sure that it lands to a node near him and with minimal number of hops, so that the latency is as low as possible. And also for the performance, that is done basically on latency, in a latency manner. So if it takes a longer time frame to respond, that means it has a poor performance.
And also to sum up all my colleagues said, basically the distribution of funds coming from the subscription fees are not done equally, but they have scores, and nodes get rewarded according to how difficult it is to run a full node, because it's different between different projects, right? They have different requirements of hardware and also by performance. So nodes will get distributed funds depending on merit.
Brilliant. So that answers the speed question, maybe, the performance speed, but what about the performance load? When the transaction load or for the bot load increases on those servers, some will start failing faster, some later. So we'll just depend upon the failing transaction calls to determine which are at their peak load and which still have space left?
Sorry, can you repeat the question?
So basically, let's assume we have two RPC providers to you guys. One is using a 8-core machine, 8-thread machine, and the other is providing a 32-thread machine. At one point, if they're both getting the equal load, the 8-core machine will start to fail, whereas the 32-core machine will still perform excellently and continue to with the higher transaction load.
Yeah, that's still for the integrity protocol. Basically, if one node fails to deliver, it will not meet the requirements, and it will get jailed, and it will not get any rewards until it fixes the issue.
Okay, so maybe let's say there's a spike in the transaction count. Let's say there's a spike in the load the node is facing, and it fails for like a minute, but after the spike cools down, it starts to perform well on its own. So would that require some sort of unjailing procedure, or would it be automatically done?
So unjailing will be automatically done. And once it gets in a good state, it automatically gets added back to the platform.
Amazing, I love it. So we at Millennium Club DAO will be gladly providing a crap ton of service to you guys. This is what we do, and I love what you guys did. Thank you so much.
Yeah, we
about the question you've asked, there is also load balancing that happens here. So we are not at the risk of loading a node too much, because that will be detected. And yeah, that was an addition.
Thank you so much.
Okay, any other questions, guys?
Yeah, I had a question regarding the DEX sniping bot. So is this meant to be done with like a hot wallet or a cold wallet?
Well, basically you have a different wallet per bot instance. It can be like a key store, for example, if I understood the question correctly. Basically, you have to use multiple wallets, but only store the funds you want to invest on the contract. Each wallet, in part, only has to pay the transaction fees for the buy.
So
was that
basically you don't need a cold wallet, because the funds are stored in the smart contract. So actually, on the smart contract, you have the money that you want to invest in that buying order. So all the other wallets are acting as a trigger. So you can think of them as oracles. So they are looking for the liquidity transaction all over the world. And the first one that emits the transaction and goes through the smart contract is the one that makes the buys for all of them. So basically, you don't need a cold wallet for that, just to secure the smart contract in a way, maybe with withdrawal function with multi-signature or something like that.
You can have some admin privileged account to store money on the contract and withdraw them if you, I don't know, gave up on trading on a specific pair or something.
So then how would you mitigate like smart contract risks when it comes to the bot? Is there anything that you would encounter while using the bot that you have to like pay attention to in terms of these risks, maybe with permissions, like spending permissions and whatever you set?
So in terms of permission to the contract, is that the question about? I cannot hear quite properly here.
Yeah, it was like, is there a chance for any like exploit or any bugs when it?
Not really. I mean, the contract only has some has an owner, for example, or you can implement it to be multi-owned and have some role-based access to it. So we have swapper wallets that you register yourself using the owner account, and just these can swap tokens and use the funds. But yeah, if the owner is compromised, an attacker can configure any trade with any other token and or withdraw your funds from it. So, but exploits, the contract is quite simple to implement. It's not like needing an audit or something like that. You have just to store the keys securely.
Got it, thanks.
Thank you for your question.
Hi, I have a follow-up question for your integrity protocol, what is the source of truth that you mentioned? Where is it coming from?
Actually, we don't want to provide all the details now of the implementation. It's not released yet, so we cannot say everything that happens inside the protocol as of yet.
Okay. I mean, it's very important for knowing how good your integrity protocol is.
We will have a test net at the end of this year, and we will announce some of these technicalities by then, but not right now.
Can you at least say if it's dynamic or each time same events?
It's dynamic.
Okay, thank you.
Are there any more questions? If not, I would like to thank you all for participating, and it was a pleasure being here. And I hope you enjoyed the presentation, and we will share the code that was used on GitHub, so we can keep in touch, and we'll let you know once it's publicly available on our GitHub handle. So thank you very much.